Welcome to Track 2 Hands-On. 15 lessons that take you from a fresh Python environment to a fine-tuned model shipping behind an API, written by hand. Raw trainer first for understanding, then TRL's SFTTrainer for production. QLoRA real metrics, structured outputs, multi-turn chat, and a project gallery to close. Code at every step. Set up the environment. Python 3.10 plus, a venv to keep it isolated, then the core libraries. Torch, transformers, peft, datasets, accelerate plus TRL. Pin to recent versions, the trainer APIs evolve. Verify the install by importing each module, and check CUDA is visible if you have a GPU. Small, focused, real. Load the model and tokenizer. Auto model for BrewSLM and auto tokenizer from the same model id. They must match. Use dtype torch.bfloat16 for memory. Pad token, many tokenizers do not have one set. Assign the ES token to be safe. Inspect what you loaded, count the parameters. Sanity check with a quick generation before training. If the base cannot speak now, training will not fix it. Build a tiny SFT dataset. Pairs of prompt and completion as Python dicts, then wrap in a datasets.dataset. Check class balance. A counter on the labels tells you immediately if you have a problem. Split into train and validation, a held-out slice you use for monitoring during training. The discipline is in what goes into the prompts and completions, not the wrapping. Tokenize and collate. For each example, apply the chat template to render user and assistant turns into a single string, tokenize it, build input HIDs and labels. Labels mask the prompt tokens to -100, so the loss covers only the assistant tokens. Then collate into rectangular batches with data collator for sec-to-sec. Pads input HIDs with the pad token and labels with -100. Inspect one example to verify. The minimal LoRA trainer. LoRA config with rank 16, alpha 32, target the QProj and VProj modules. Wrap with get peft model. Training arguments, learning rate 2e-4, 3 epochs, BF16, save and eval every epoch. Pass model, args, datasets, collator, tokenizer to trainer, call train. About 30 lines end to end. Save model writes only the adapter, a few megabytes, not gigabytes. Run it and read the logs. Trainer prints loss every logging steps, watch the trajectory, not any single value. Training loss should fall steadily, eval loss should follow. Checkpoints land and output, dire at each save step. After the run, look at the eval loss curve to decide which checkpoint to keep. Eval loss going down is necessary but not sufficient. Real verification is the gold set. Evaluate by hand. Load the base again, attach the adapter with peft model from pretrained, base plus adapter, not the merged file. Write a small prediction helper that greedy decodes with do sample false. Score the gold set, tally correct versus wrong. And read the failures by example, not just the score. A model that wins on aggregates while failing on a specific shape is hiding a problem your eval has to surface. Merge the adapter and ship the artifact. Merge and unload combines the LoRA matrices into the base weights. The result is a standalone model with no PEFT dependency at inference. Save with save pretrained, reload as if it were any other model. For deployment, pick the format. SAFA tensors for HF and VLLM, GGUF for llama.cpp and edge. Capstone A, the whole pipeline in one script. Environment, load, dataset, tokenize, mask, train, eval, merge, ship. Success criteria up front. The lift over baseline, the gold set must show before you call it done. About 100 lines total. You now have a working fine-tune from scratch by hand with every line under your control. That is the point of Track 2. Now graduate to TRL's SFTTrainer, the 20-line version of what you just wrote by hand. SFTTrainer wraps everything: chat template, loss mask, PEFT integration. You give it chat messages data, set completion only loss true, pass peft config, call train. Same training, dramatically less code. Reach for raw trainer only when you need a custom loss or non-chat data shape. QLoRA hands-on. Install bits and bytes. Bits and bytes config with NF4 quantization, BF16 compute D-type, double quantization. Load the base in 4-bit, call prepare model for K-bit training. Attach LoRA with wider target modules, Q, K, V, O plus the MLP projections. Then SFTTrainer as before. A 1.5B model fits, where 135M used to fit at full precision. Real metrics. sklearn's classification report gives you per class precision, recall, F1 and support in one call, the right default for any classification eval. Confusion matrix shows where the misses go. Macro F1 weights classes equally. Micro weights by support, on imbalanced data, macro tells the honest story. HF evaluate is the shared standard interface used in papers. Structured outputs need 2 numbers. Define a Pydantic schema for the JSON the model should emit. Parse model output through Pydantic track JSON parse failures and schema validation failures separately. Report 2 numbers, valid JSON rate and per field accuracy on the parses that succeed. Either alone is misleading. 95% valid JSON with 60% accuracy on the totals is broken in production. Multi-turn chat SFT. Data shape, chat messages format, but each conversation has multiple user assistant turns. The loss mask covers every assistant turn, not just the last. SFTTrainer's completion-only loss handles this. Verify by dumping one batch's labels and decoding the unmasked positions should be assistant content only. Pitfalls, max sec length truncates the final turn. The small model cannot hold long context. Project gallery. 6 concrete SLM use cases, each one a recipe. Sentiment classifier, done. Intent classifier, multi-class, balance the minority intents. JSON extractor, Pydantic validation. PII detector, span extraction, recall is the metric to defend. FAQ assistant, RAG plus a small SFT for tone and refusals. Tool call generator, schema-driven JSON. Pick one. Ship one. The skills transfer, the experience of getting through a pipeline does not. That is track 2. You can fine-tune small models in Python by hand and with TRL, evaluate them honestly, ship them as real artifacts. Track 3 takes the same pipeline and runs it through BrewSLM, same mechanics, less plumbing, and the audit trail that makes the whole loop reproducible. See you there.